previous video, we looked at the general method used to conduct a hypothesis test. There are 6 main steps that all hypothesis tests require, and they all have the same rejection criteria for the p-value. However, each test may have a different null and alternative hypothesis, different assumptions to check, and their own test statistics. In this video, we'll now look at 2 of the tests that you need to know in first-year statistics. The first is the one-sample z-test, and the second is the one-sample t-test. We will only cover two-sided hypothesis tests in this video. However, it should be noted that there are also one-sided hypothesis tests, which we will not be covering as they are not generally covered in first-year courses. So how do we know when to use a one-sample z-test or one-sample t-test? Let us look at the similarities first. Firstly, both hypothesis tests are used to investigate whether the sample mean differs from the predefined population mean given in the research question. This means that both tests have the same null and alternative hypothesis. The null hypothesis H0 states that the mean mu is equal to this predefined population mean denoted by mu0, while the alternative hypothesis H1 states that the mean is not equal to this predefined population mean, and that there is evidence that the mean is greater than or less than the population mean. The second similarity is that they have the same assumption that needs to be checked, that is, whether the sample mean is drawn from a normal distribution. There are 2 options to do this. The first option to check this assumption is to use a central limit theorem. This can be done if the sample is large enough, which we define as a sample size greater than or equal to 25. If the sample is large enough, we may use the central limit theorem to state that the sampling distribution of the sample mean y bar will be approximately normal. The second option is to plot the histogram of the data and see if the graph is shaped like a bell. This would also prove that sampling distribution of the sample mean y bar is normal. So now, how do we know which test to use? The answer is to check if you know the standard deviation of the population, sigma. If you do know the population standard deviation, you can use the one-sample z-test. However, if you do not know the population standard deviation, sigma, we must use the one-sample t-test and instead use the sample standard deviation, s, as an estimate of the population standard deviation. Now that we know which test to use, let's look at some examples of each test. The research question is the mean systolic blood pressure of a sample of patients the same as the systolic blood pressure of a population X? We are told that the mean systolic blood pressure in population X is 140 millimeters of mercury, and that the standard deviation is known to be 20. We are given a sample of 55 patients and their systolic blood pressure in millimeters of mercury. So firstly, let us identify the test that we will be using to answer the research question. We have the population's mean systolic blood pressure, and we have the population's systolic blood pressure standard deviation, known as sigma. This means we can use a one-sample z-test. Let's recall the 6 steps in the hypothesis testing method. The first step is to state the hypothesis. To answer our research question, our hypothesis can be stated as such. The null hypothesis is that the mean mu of the systolic blood pressure is equal to 140 millimeters of mercury. The alternative hypothesis is that the mean mu of the systolic blood pressure is not equal to 140 millimeters of mercury, and that there is evidence that it is greater than or less than 140 millimeters of mercury. Next, are our assumptions satisfied? Well, our sample size, n, is 55. This is larger than 25. Hence, we are able to use the central limit theorem to state that the sample mean must be approximately normally distributed. Great, so now we are ready to calculate the test statistic. The z-test statistic is z is equal to the difference between the sample mean y bar and the predefined population mean mu, divided by the quotient of the population standard deviation, sigma, and the square root of the sample size, n. We have mu, n, and sigma. As we have the sample data, we can use Excel to calculate the sample mean. The sample mean is found to be 130 millimeters of mercury. We can now substitute all the given values into the test statistic equation to calculate Z. We then find Z to be negative 3.7081. We're now ready for step 4 to find the p-value. The p-value is 0.000209. The p-value for the z-test can be found in Excel using the following Excel function with the test statistic. Our p-value is less than 0.05. We can now make a decision to either reject or not reject the null hypothesis based on our p-value. As our p-value is smaller than 0.05, we reject the null hypothesis. It's now time to consider our research question as we write our conclusion in the final step. There is strong evidence that the mean systolic blood pressure of the sample patients is significantly different to population X's. Rather, the sample population mean is less than 140 millimeters of mercury. Let us now look at another example. The research question is the average test score of the 20 sample students the same as the previous year's average test score? We are given that the previous year's average test score is 100. We can see the data set of the 20 students' test scores. So now the question is, which hypothesis test should we use? Well, we have the population mean, but do we have the population standard deviation? No, we do not have the population standard deviation. Okay, so now we know that we must use the one sample t-test as the population standard deviation is unknown. Let's start with the first step of the hypothesis testing method. Once again, we need to state our hypothesis that will answer the research question. The null hypothesis is that the mean test score mu is 100. The alternative hypothesis is that the mean test score mu is not equal to 100. Therefore, there is evidence that it is greater than or less than 100. The next step is to check our assumption of normality. Recall that our sample size n is 20, which means we should not use the central limit theorem to assume normality. Instead, we should check the histogram of the test scores. The histogram is fairly close to a bell shape, so we can assume that our sample mean must be approximately normally distributed, and therefore we can continue on to our next step, calculating the test statistic. The test statistic is t is equal to the difference between the sample mean y bar and the predefined population mean mu, divided by the quotient of the sample standard deviation, denoted as S, and the square root of the sample size n. We now have to consider the degrees of freedom in the t-test, denoted df. The degrees of freedom is the number of values that are independent and hence are free to vary. You can use this QR code to watch a video from Professor Essa on YouTube, where she further explains degrees of freedom. Let's relook at the t-test test statistic. We know mu and n. However, we don't have the sample mean, y bar, and the standard deviation, s. Again, we can use Excel to calculate the sample mean. The sample mean is found to be 98.7. We can also use Excel to find the sample standard deviation, which we find to be 13.727. Excellent! Now we have everything to calculate the test statistic. We can substitute all the values we have into the test statistic equation to calculate t. This gives us t to be negative 0.4235 with 19 degrees of freedom, which we calculated using the given value of n. It's time for the fourth step, to find the p-value. The p-value we find is 0.6767. The p-value for the t-test can be found in Excel using the following Excel function with the test statistic and the degrees of freedom. We also know that our p-value is greater than 0.05. We can now move on to the fifth step to make a decision to either reject or not reject the null hypothesis based on our p-value. As our p-value is greater than 0.05, we do not reject the null hypothesis. Finally, let's consider our research question as we write our conclusion in the last step. There isn't enough evidence to say that the average test score of the students is different to the average test score of the previous year. Rather, the average test scores may be the same. Let's recap. We have used the 6 steps of a hypothesis test to look at 2 examples of hypothesis testing, one for the one-sample z-test and one for the one-sample t-test. We know that we need to use a one-sample z-test when we know the population standard deviation. However, if we don't, we need to use a one-sample t-test with the sample standard deviation as an estimate. In the one-sample z-test, we found the p-value to be less than 0.05, which led us to rejecting the null hypothesis. On the other hand, in our one-sample t-test example, we found a p-value that was greater than 0.05, which led us to a different conclusion to not reject the null hypothesis. I hope this helps you to better understand hypothesis testing.